For over 70 years, the fundamental blueprint of commercial aviation has been completely stuck in a rut. Every passenger jet you have ever flown on is built using the exact same standard configuration: a long metal tube with wings attached to the sides. But deep inside a cavernous aircraft hangar in the Mojave Desert, an aggressive California startup is building a full-scale assault on that traditional design. JetZero is finalizing construction on a radical manta-ray-shaped aircraft known as the Z4. Backed by over $1 billion in funding, this machine promises to slash fuel consumption by up to 50%. While mainstream analysts originally dismissed JetZero as a highly speculative, long-shot gamble, the global aviation establishment just threw massive financial legitimacy behind the project. At the Farnborough International Airshow, major legacy carriers Japan Airlines and Gulf Air officially signed agreements to secure preferential delivery slots for the future Z4 airliner. This adds to an elite list of early strategic partners that already includes United Airlines, Alaska Airlines, and Delta. A startup with zero history of mass aircraft manufacturing has successfully cornered the interest of the world's most powerful commercial carriers. To understand why legacy airline executives are pulling out their corporate checkbooks, we have to look past the futuristic aesthetic and analyze the core physics of a blended wing-body airliner. In a traditional aircraft design, only the wings generate lift. The long cylindrical fuselage is essentially aerodynamic dead weight that the engines must drag through the air. JetZero completely eliminates this penalty by merging the passenger cabin, wings, and fuselage into a single continuous lifting surface. The entire airplane acts as one giant wing, resulting in a quantum leap in efficiency that standard tube designs can no longer match. Today, we are tearing down the industrial blueprints to expose the hidden economics and infrastructure strategy backing JetZero's radical campaign. How does the Z4 achieve a 50% fuel burn reduction without requiring expensive new hybrid or hydrogen propulsion tech? How is the United States Air Force acting as a secret funding shield to bypass commercial startup risks? And why is this manta-ray jet making Airbus and Boeing deeply uncomfortable about the next decade of aviation? The graveyard of aviation history is filled with brilliant, radical concepts that failed because they required completely new global infrastructure to work. JetZero's strategic genius is that the Z4 is designed to be an absolute drop-in disruption. Unlike hydrogen or pure electric flight concepts that require entirely new airport fueling grids, the Z4 runs on conventional turbofan engines and standard Jet A fuel. In fact, the full-scale flight demonstrator currently under construction in the Mojave Desert is being powered by legacy Pratt & Whitney PW2000 engines, the exact same workhorse hardware found on the Boeing 757. By utilizing existing engine tech, JetZero shifts the entire burden of innovation onto airframe geometry alone. The production Z4 features a 213-foot wingspan, which is intentionally engineered to fit inside the exact same airport gates, taxiway corridors, and maintenance bays currently used by standard wide-body airliners. This eliminates billions of dollars in airport modification penalties. Inside, however, the standard layout is completely transformed. The tube is replaced by an ultra-wide, triangular dual-aisle cabin capable of seating 250 passengers in an unprecedented level of comfort. Under normal free market capital structures, launching a clean-sheet commercial aircraft program from absolute scratch is a textbook recipe for financial ruin. The development and certification costs are so astronomical that private venture capital almost always backs away. But JetZero possesses an ultimate corporate shield: the United States Air Force. In August 2023, The US military awarded JetZero a massive $235 million contract to construct a full-scale flying demonstrator, designated as a vital precursor for next-generation military tankers and strategic cargo haulers. This military backing acts as a powerful financial subsidy for JetZero's commercial aspirations. The United States Air Force is effectively bankrolling the expensive, high-risk early engineering, aerodynamic validation, and flight testing phases of the airframe. This defense infrastructure shield allows JetZero to advance toward its high-stakes late 2027 first flight target, while remaining completely insulated from the immediate cash flow crises that traditionally kill aviation startups. It is a commercial project being incubated inside America's defense industrial complex. To prove to legacy carriers like Japan Airlines and United Airlines that they can actually deliver on their promises, JetZero has shifted away from simple digital concepts and began creating hard industrial facts on the ground. In June 2026, the company officially broke ground on its first massive manufacturing and final assembly campus in Greensboro, North Carolina. This represents an enormous 8 million square foot factory complex sprawling across more than 600 acres of industrial land. The Greensboro facility is being engineered to run an entirely new manufacturing philosophy known as co-curing. Instead of assembling thousands of individual aluminum sheets using millions of heavy rivets and metal fasteners, the traditional process that slows down Boeing and Airbus assembly lines, JetZero builds giant, unified carbon fiber sections and cures them all at once inside specialized atmospheric heat layers. This co-curing technique creates an incredibly lightweight, single solid piece airframe structure with fewer failure joints, drastically reducing production overhead and laying a direct path to hit serial production targets by the early 2030s. The structural threat JetZero poses to Airbus and Boeing goes far beyond basic startup competition. Because traditional tube and wing aerodynamic optimizations have hit a flat engineering plateau, the legacy giants can only squeeze tiny, single-digit efficiency gains out of their next-generation updates. JetZero's Z4 captures a massive 30% aerodynamic gain from its shape alone, before you even factor in advanced engine technology. This performance gap renders conventional single-aisle airliners obsolete on a pure unit operating cost basis. As global airlines face intensifying carbon caps and highly volatile fuel markets, they can no longer afford to ignore a 50% reduction in seat-mile fuel burn. By pairing US military capital with locked-in commercial fleet options from global carriers, JetZero is quietly executing a masterclass in market disruption. They aren't trying to beat Airbus and Boeing at their own game. They are simply changing the shape of the sky forever.